Hello, algebra students. Mr. Lawrence here with your flipped lesson, and we're going to review a little bit about multiplying exponents. Understand, I'm not mad or disappointed. I was a little surprised that you had so much difficulty with it on Friday. That's okay. We can take a little time and make sure we've mastered it. It's such an important concept. Yes, I'm not angry about that, of course. It's okay when you're not understanding, as long as you're doing your best. And I think many of you are doing your best. Many of you were from the beginning, and then a few phone calls to mom or dad, and most of you are now. Anyway, here we go. We're going to be multiplying exponents. Now remember, we don't want to memorize shortcuts. Shortcuts are a dangerous thing if you don't understand why you're using them. Let's always think about what's going on. Now, some of you have the shortcut down and you're really good at it. You go ahead and use it. That's not my issue. My issue is with the person who's not quite getting it, trying to memorize the shortcut, and then they're having trouble with it. Okay, they're going to get this shortcut mixed up with another shortcut and another shortcut. Oh, by the way, um, some of you watched a video in study hall with Mrs. Bell. And you're actually going to be a little bit ahead because after Friday, I reflected on what happened and I thought, you know what? I'm going to slide another multiplying exponents in. So if you watch the dividing monomials, I should call it monomials. I have this wrong. Excuse me. I didn't realize I did that. Um, if you've already watched that, you're actually a video ahead. Sorry about Sorry about that. I had a little interruption. My son came in upset over something really important. Anyway, I should have said multiplying monomials. Excuse me, my mistake. All right, uh, so the point was some of you are going to be a little bit ahead when you watch this video because we're not going to be dividing monomials on Monday. That's okay. You're just a little bit ahead. You have a choice. You can go back and rewatch the dividing videos. If you took good notes on it and you think you're ready to try it on Tuesday, that's wonderful. By the way, we'll probably be doing some kind of assessment, a little quiz coming up, say Wednesday or Thursday-ish. Make sure you're staying up on your work. All right, so here we have problem number one, and we have a coefficient of 8 and a coefficient of 2. We have an x squared, which really means x times x, right? And we have a y cubed, which means y times y times y. Okay, here we have a plain old x, and here we have a y to the fifth, which is 5y's being multiplied together. We don't want to say it as 5y's. We want to specify that they're 5y's being multiplied together. If we just say 5y's, then we might be misleading the reader or the listener to think we're adding those y's together. Okay, so I'm going to multiply my coefficients, and I'll get 16. And then I'm going to multiply my x's. Well, I've got 2 here, and I've got 1 here. How many x's are being multiplied together? 3. Okay, and I do know some of you know the shortcut, and you're not going to do it this way, and I'm fine with that. But I'm doing it this way for the people who don't get it. I don't want them to memorize the shortcut. Do you think I've said that enough times? Okay, so now we have y to the third, which is y times y times y, and y to the fifth, y times y times y times y times y. Well, how many y's are being multiplied together? 8. And instead of saying y times 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 y, I can just say y to the 8th power. Why don't you try problem number 2 on yourself? I'm going to give you a warning. It's a push-up question. Don't get it wrong. Don't get it wrong, because I'm going to make you do the push-ups on it. We'll combine physical fitness and mathematics. You'll have strong minds and strong bodies. All right. I'm assuming you've done it by now. You could, of course, pause the video if you haven't, but I'm going to get ready to do it. I'm going to multiply 5 times 3 times 2. But remember, multiplication is commutative. The commutative property allows me to change the order. So I think I'm going to multiply 2 times 5 and get 10, and then multiply by 3 and get 30. Yes, multiplication is commutative. It is totally okay to do that. You might not like doing that, but sometimes it's smarter to change the order in your multiplication than it is to just multiply. Let me get rid of that. Okay, now I'm going to multiply my x's. Now remember, if you don't see an exponent, you assume there's a 1 there because there's only one x. Okay, now when I multiply, I get x times x times x. Well, that would be 3x's being multiplied, or x cubed. And there is my answer, right? If you thought it was 30x, then you got to drop and give me 5. Go on, do it. Come on, give me 5. Count them off. Okay, let's go on to problem number 3. I'm going to multiply my coefficients. I've got a negative 10 and a 4. Let's say I'll have a negative 40. I'm going to look at my x's. I've got x to the 5th times x cubed. 5 x's, 3 more x's. I must have 8 x's being multiplied. Now I have a y here and a y here. Oh, I'm sorry, I have a y to the 4th here and a y there. And when I multiply those together, aren't I going to have 5 y's being multiplied? Now this is going to freak some of you out. You're going to go, wait, there's no z over here. Well, dude, it's all multiplication. Just chill. Just bring the z along for the ride. Yeah, no problem. Now, for those of you who are really advanced, I'm just going to show you something really quick. If you don't get this right now, you'll get it in a few days. You could think about a z to the 0 being there. Let me ask you this. If I do z to the 0 times z to the 5th, and I got z to the 5th, what number must z to the 0 equal? All right, I'm not going to answer that. You look at that. If I multiply a z to the 0 times a z to the 5th, and I get z to the 5th, what must z to the 0 power equal? Okay, see if you can tell me that on Monday. Have it written down on your notes and say, hey, z to the 0 equals, but don't put question mark. You put what it does, because this is really super simple. All you have to do is think about it a little bit. I multiplied this number by this number, and the original number, the z to the 5th, didn't change. Hint, 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 hint. Okay, let's go down to problem number 4. I have 3 quantities being multiplied. Well, I've got 4, 3, and negative 5 all being multiplied. I think I'm going to use the commutative property and multiply 5 times 4 and get negative 20 because it's a negative 5. And then I'll multiply that by a 3 and I'll get a negative 60. Yeah, I can do that. 4 times 3 times negative 5 is the same problem as 4 times negative 5 times 3. Yeah, they're the same problem. Okay, now I've got x cubed times x, and there's no x's here. So by the way, there's not 0 x's. I don't want to say it that way because if there's a 0 in here and I have to multiply everything by 0, wouldn't that change the whole quantity to 0? Right? So I'm not going to think about it that way. I'm just going to notice that there aren't any x's in the expression in that particular monomial, and so I'm only going to worry about the x's I have. 3 x's in the first quantity, 1 x in the second, and there we go. And again, if you want to, you can stick that little 1 there. All right, going to multiply by y's. They're not, the y doesn't show up in the second quantity. Shows up in the third. I'll stick that little 1 for an exponent. Y squared times y is going to be y cubed. Z's, I've got a z to the first, sticking my little 1 exponent in, a z to the 5th, and a z to the 8th. Looks like that's going to be z to the 14th. There you go. Pretty easy stuff. All right, one last question. Find the area and perimeter of this square. It has a side of 2x squared y centimeters long. Well, let's see here. Do you remember how to do the area of a square? This should be pretty basic. Area of a square. I love to use the definition of base times height, and as we go along, you'll see why I use base times height. I don't use length times width. I don't use all the other formulas. I mean, if you know the way the OA is written, they go, well, the area of a square is the side squared. Okay, and then they say the area of a rectangle is length times width. And then they say the area of a triangle is 1/2 base times height. Okay, and then they say the area of a rhombus or parallelogram are base times height. And they also say what the area of a trapezoid is average of the bases times the height. And then even the area of a circle is, oops, it doesn't look like a circle. There we go. Uh, Pi r squared. Okay, and I can use actually one formula to calculate all these different shapes. This 1, 2, 3, 4, 5, 6, 7 shapes. I'd rather use one formula. I just use base times height for all of them. And then I modify it based on what the shape is if I need to. And I'll explain more about that as we go on, as we do some little OAA prep as we get nearer to the test. But I'll show you that why memorize 7 formulas when you can memorize one and just modify it a little bit. And it works very well. A lot less confusing. Okay. All right. So anyway, area is base times height. Well, the base and height of a shape are identified by their right angle. Please don't think that the base is the bottom. That is like the worst definition I've ever heard. Base and height come together at a right angle. Since it's a square, I have 4 right angles. I could call any side the base and any side touching it the height. So, for example, most of you would like to say, well, this side here is the base, and you can do that. And then you could say that this side here is the height. Or you could have said the right side was the height. Okay, either one would be fine. So to find my area, I am going to multiply the base times the height. I'm going to take the base, which is 2x squared y centimeters. And I'm going to take the height, which is 2x squared y centimeters. Okay? And I'm going to multiply 2 times 2 and get 4. I'm going to multiply x squared times x squared, and I'm going to get x to the 4th. Y times y is going to be y squared. Now, a lot of you get really screwed up on using the right units. If you think about multiplying monomials, you'll never get this wrong again. Look what we're multiplying right here. Can't find my highlighter, sorry about that. We're multiplying a centimeter, pardon me, got the hiccups, times a centimeter. Well, wouldn't that be like centimeters to the first power and centimeters to the first power? So my unit should be centimeters to the second power, or centimeters squared, or square centimeters. You should never get that wrong again, because just pay attention to your units in your multiplication. Okay, if we're doing volume of a, say, a cube, well, the volume of a cube, you have to multiply 3 sides together, right? Okay, so the volume of a cube, let's pretend the cube was 8 inches on each edge. Okay, so you would take 8 inches and you would multiply by 8 inches and you would multiply by 8 inches. Okay, now I think this might be 324. 8 cubed, I think might be 324. Let me check myself. 8 times 8 is 64. 8, we're going to get what? 2, we're going to get 3. Oh, it's got to be more than that. 524. There we go. That makes more sense. 512. Oh, look at that. My math skills are a little, sorry. It's a little early in the morning. Good excuse, Mr. Lawrence. Sorry. 48 and 3 is 51. So it's 512. Then I'm doing inches times inches times inches, which is going to be inches to the third power, or inches cubed. Never get that wrong again. It's too simple. All right. So there is my area. Now I have to do perimeter, and then we can wrap this video up. All right. The perimeter, of course, is the distance around the square. And maybe I'll do a little demonstration in class that will help reinforce that. So the distance around the square, I like to think of taking a walk around the square. Okay, so I'm going to ask myself, how far did I walk? Well, if I start at this corner and I walk here, I've walked 2x squared y centimeters, right? 2x squared y centimeters. Okay, and if I walked to here, I've gone another 2x squared y centimeters. So I've got another 2x squared y centimeters, and I'm feeling rather lazy, so I'm going to do this. There we go. Okay, and then if I go here, I'm going to go another 2x squared y centimeters, which should be shroop. I'm running out of room here. And then, of course, I have to do the return to the starting point, and that would be one more 2x squared y centimeters. Now remember, in addition, we're just counting how many we have. In this problem, what is it that we're counting? We're counting the x squared y centimeters. X squared, how many x squared y centimeters do I have? Well, your initial thought might be 4, but I disagree with that because right here I have 2x squared y centimeters. Here I have 2 more. Here I have 2 more. Here I have 2 more. So I must have 8 of these x squared y centimeters. This is just, whoa, what the heck is that? Okay, this is just combining like terms. The exponents don't change because I'm just counting how many I have. For example, 5x plus 3x. How many x's are we adding together? We're adding 8 x's. The exponents don't change because we're not multiplying. Okay, that's it for your lesson. Mr. Lawrence signing off. Have a good night, everybody.